So that is called motion. So in simple words we can say that motion is, this is the exact definition of motion, changing of position with respect to time. So I don't know whether you have noticed or not, when I was entering the classroom, you might have noticed, I was exactly outside when sir was introducing me. I have got into the class. The position of mine was outside. After some time, my position changed inside the classroom. First step, second step, third step, and finally I have walked into the class. Then you will say that sir is in motion. So this is called motion. For example, we can fix a position here. This is position P1. If you consider this object is changing its position from here to another position, finally it will reach here. This is P2. We can say that this object initially was here. This is the initial position and final position is here. What is occurred here? That is called a motion. This is called a motion. So what is motion? Motion is changing of position with respect to time. Today in the class we are going to discuss about two types of motions. What are the two types of motion? Before telling about two types of motion, I would like to tell you about some of the students in the classroom. You consider some of our friends. Three of us. Anyone from you. They are going to school. This is a position. It is, imagine, would you mind stand up there? You stand. Okay, you stand up. And finally you stand up. Here, we have three students here. This is the position of him. I'm calling you as A. And this is your position, I'm calling you as B. And it's you and it's C. Okay. And here is our school. This is our school. Position of school. So you three are aiming to school from your house. This is the place where is your house. So what happened here? I'm giving you time. And we all are observing. We all are the observers. These three are actually on the ground and we are the observers. We are all observing them. What they are doing here, they are about to go to the school. Since you are being the first one and you are going to the school, what happened? We will give them 5 minutes. 5 minutes is the time. Correct, no? And the minutes are the units of that particular unit of time. So what we are doing is we are giving them a time. Since we are giving them a time, then what will happen? We can simply observe what we have. He is actually 5 minutes I have given. In 5 minutes he has covered this much distance. Then what he is doing? He is changing his position from here to here. Then what he is doing? He is moving, right? Exactly, he is in motion. In 5 minutes, what she has done is she is here. She is here, right? After 5 minutes, she is reached here. And again, 5 minutes we are giving to this guy, the particular one, it is him. What happened? 5 minutes we have given him, he is here. There, after 5 minutes, he is here. Okay? Again 5 minutes we have. Again 5 minutes. After 5 minutes, what happened to the first one? First one is here. What is the total time? 5 minutes. 5 minutes. And total time is 10 minutes. Has covered 10 minutes and almost the position of this initial position was here. After 5 minutes, he is reaching here, and again after 5 minutes, he is finally here. She is here. 5 minutes we have. Can you see the change in the position? So we can call he is in motion. She is also in motion. What finally happened here, and I'm going to show you another thing. The miracle I'm going to show you. What happened to him? That guy, it is him. He's all our particular friend, and he's standing on the same place. His position is here. After 10 minutes, he's over where? Here. Okay. After 15 minutes, this guy is reached in school. She's almost here. I have given her around 20 minutes. She reached to the school. He has taken 15 minutes to reach to the school. She has taken around 20 minutes to take this school. But look at him. After 20 minutes, he's here only. What is it called? One guy, these two girls are actually in motion, and the other one is in rest. What is rest? What is the definition for rest? Stand and tell me. Try to tell. Observe the situation and tell me what is the definition for rest. Rest, motion I will tell you. What is motion? Motion is changing of position with the time. We already know that one. Then we can, according to definition, we can easily say that one. These two objects, or these two students, they are in motion. But what happened to him? He is not changing his position with respect to time. Then what is rest? Rest is actually not changing of position with respect to time. So then time is why you can observe everything inside this classroom. Can you have a look on the fan? We can have a look on the fan. We can have a look on everything inside this classroom, every non-living thing inside this classroom, and we are going to see that every non-living thing is not changing their position with respect to time. Can we give 10 minutes? Yeah. Look at the green ball. We can give 10 minutes. 10 hours we can give. Okay, 10 years we can give. For example, after 10 years when we come to the your previous school and you are going to see the same green board will be here. Green board is not changing its position with respect to time. It is called rest. Understood? Then today we have studied about the definition for motion and rest. Okay. Everyone knows about the definition of motion and rest. If I am asking you, then you all are having the constant answer. Motion is changing of position with respect to time. The rest is not changing of position with respect to time. So the time is moving forward. Since the time is moving forward, what we are having is changing of position. We can call as motion. Many examples are there. Consider our bluish planet. We can call it as our. Consider our solar system. Sun. Actually, our sun is moving around the. You all are thinking that our sun is at rest. The sun is not at rest. The sun is moving around the galaxy. The name of our galaxy is Milky Way. At the center of our Milky Way galaxy, there is a black hole. What is the name of it? Sagittarius. Around the Sagittarius black hole, our sun is revolving. You might have studied in the lower classes like you might have heard from your parents and grandparents, our sun is at rest and all other planets are revolving around it. It's not like that, our sun is not at rest, the sun is revolving around our galaxy. Same like how Earth is revolving around our sun. Okay. So everything in our universe is in motion. So the first step to the universal study is learning about motion. We understood what is motion. Two types of motions are there, uniform motion and non-uniform motion. Introduction to uniform motion and non-uniform motion is the very important thing. When you are going to study about non-uniform motion, you have to know about every 9th class physics, every 9th class science. You should. Then only you will be able to say about what? Non-uniform. So today I am going to teach you about uniform motion and non-uniform. I hope that you all have understood about motion. So can you please stand up what is motion?
Changing of position with the help of time.
With respect to time, not with the help of time. Time is like it won't wait for anyone. Time will not wait for anyone. It moves forward. Yeah. So I have introduced you one of the physical quantity. Can you tell me what is the physical quantity? That is time. Okay, we will not wait for anyone. We have to consider. We have to make our own equations according to time. So that is clear. Then what is rest? Rest means what? It is not changing its position with time. Correct, no? So non-uniform motion. First I will tell you about uniform motion. Definition is very simple. You have already studied this one in the lower classes, but as opposed to your lower classes, 9th class science is having a rhythm. It's kind of different. So listen to me. Uniform motion and non-uniform motion. First, uniform motion. Uniform motion is actually it is equal distance covered in equal intervals of time. That is a definition you might have studied in your lower class. Equal distance covered in equal intervals of time in a straight line is called a uniform motion. Uniform motion is an object is covering equal distance in equal intervals of time. Is called uniform motion. I'll show you an example. Stand up here. Come. Uniform motion is not very complicated. To understand this, I'm going to show you an analogy. Who do we have here? What's your name? He's here, standing here. It's very hefty. Okay, so you stand here and you observe the place. Can you see the place? Yeah. So today he is going to cover a distance. We all know that one. What is motion? Simply, okay, can you walk around? Yeah. Can you see that one? We are counting 1, 2, 3, 4, 5, 6. The 1, 2, 3, 5, 1, 2, 3, 4, 5, 6 is just the time, mentioning of time. 1 second, 2 seconds, 3 seconds. So what would happen to see here? He's changing his position. His initial position was here. Right now he's over there. Can you see the position is changed? So now he changed his position from here to there. We can call it as motion. Exactly, there it is. But there is a problem. Did you notice that? Come back.
Jadid sir,
Yeah.
after this function term, sometimes you take the biology class.
Sure.
Sure. Okay. Actually,
Okay, you observe this guy, and you can see around once when he is moving from here, like wait, this is just going to go for one step. This is one step, and here should be the second step. The lines you have when we count one, we have to go for the first step. We don't stop. Okay, got it. Yeah. So we can see what he's going to do right now. Yeah. First step. 1, first step, second step, yeah, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is called uniform motion. What happened here? You might have observed that right now he is having a rhythm. What is that rhythm for? This rhythm is actually, I can show you in a way. You know what? Equal distance he is covering according to equal intervals of time. What did I do? Once more you do that. Don't stop there. Once first, no, not like that. We'll cover the lines. First step on the first line. Yeah, second line. Which line? This is okay. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. According to the time. Time is uniform. What is that? 1 second, 1 meter. Imagine that this one, like the brick is showing 1 meter there. We can right now write the information like here. In first 1 second, the object is covered 1 meter. Second, next to 1 second, what happened? It is going 2 meters. That means 1 more meter extra. Next to 1 second, what happened? The object is gone 3 meters. 1, 2, 3 meters. Correct now? So, what is that? Next to 1 meter extra. Correct now? That means each and every 1 second, what happened? The object is going 1 meter, 1 meter, 1 meter like that. Did you see that? So this is called uniform motion. What is uniform motion? Covering of equal distance in equal intervals of time is called a uniform motion. What is non-uniform motion? Non-uniform motion is actually not covering, for example, it's opposite. What is it? In equal intervals of time it will cover unequal distance. For example, you come here, you walk as you wish, slowly. Increase your speed and slowly increase your speed. You can see here, it's not in uniform motion right. For example, imagine that there is a vehicle on the road. The road is okay. The road is not with heavy traffic. The road is not jam-packed. We can see some of the vehicles are moving from one place to another place. It will be very fast if it is a block. Otherwise, if imagine that this road is in Bangalore, then how it will be? We can imagine a situation. The road will be very jam-packed. The speed of the vehicle will be not controlled by the driver. We can't custom that. Sometimes it will be very fast, sometimes it will be very slow. We'll look at the mobile and others will look at the watch and we'll predict, I have to reach there, so I have to go faster. So the driver will custom the speed, but all of a sudden the block. So what motion is this one? This is called a non-uniform motion. What is the specialty of non-uniform motion? Unequal distance it will cover in equal intervals of time. For example, 1 second. it will go 1 meter. Next 1 second it will go 10 meter. Next 1 second it will go again 1 meter. Next 1 second it will go 0 meter. Next 1 second it will go 100 meter. Like that, each and every 1 second the object will go non-uniform way is called a non-uniform motion. Clear or not? Correct. So, according to me, what I'm going to tell you is uniform motion and non-uniform motion we can label on the board. How we can label this on the board? For that, what we are having is the assistance of time. According to time, we can label that. So, uniform motion is very clear to you. Once more, I will tell you, one object is covering equal distance in equal intervals of time. That means first 1 second. For example, look at me here. One object is here. In first 1 second, that object will go here. Next 1 second, here. Next 1 second, here. Next 1 second, here. That means each and every, I will draw that one on the board. Observe this object. One object is here. In first 1 second, that object will cover 5 meters. Next 1 second, this object will cover again 5 meters. Next 1 second, this object will cover again 5 meters. Next 1 second, this object will cover 5 meters. The total distance is covered is 20 meters. Correct now? And what is the? You just count 1 second, 1 second, 1 second. What is that? 1, 2, 3, 4 seconds. The object covered 20 meters. But you observe in first 1 second, 5 meters. Next 1 second, 5 meters. Next 1 second, 5 meters. This is called a uniformly undergoing motion. Okay, clear? Okay, so this is actually all about our uniform motion and non-uniform motion. So let's ask this question to, I was telling you about our bluish planet. Bluish planet is our, why is the color of our Earth is in blue color? What is the reason of this color is something is in blue color? It's because of reflection of light. We call it as reflection. When light will reflect, we will see something in different colors. Light will, what is the reflection of light will decide we needed to see that object in which color. Correct now? So we can go back to our Earth. What is there in our Earth? In our Earth, what do we have? What do we have in our Earth? Life. That is a speciality of our planet. Okay. Life is actually existing in our Earth. Okay. So, what is our Earth is made up of? Some of the, from where our Earth is erupted? So many questions are there. From where our Earth is erupted? Our Earth is erupted from Sun. 4 billion years ago. Our Earth is erupted from Sun. I am switching the subject physics to chemistry. That's why I'm giving you the connection. So let's go to chemistry. So we know about our Sun is the. So I will tell you one question I will ask. Your body is made up of cells. Correct. Let me ask you this question constantly. If I am asking this question constantly, you can have many answers. What is there in the cell? Cell is made up of nitrogen. So nitrogen is the element present in your body. Nitrogen is there. Calcium is there in your teeth. Phosphorus is in your bone. Iron is in your blood. For example, you might be knowing about some of the dishes that you get from the shop. What is that? Some of the, what is that? Vada and all. These all things are actually made up of carbon. So the food is made up of carbon. Once more, the nitrogen in your DNA, the calcium in your teeth, the iron in your blood, and carbon in your apple pies. That means the food that you are having is all made in the ingredients of our sun. This phenomenon we are actually calling as nucleosynthesis. That means right now whatever is there in our body, everything is actually synthesized in our parent star called sun. That means you are all star stuff. Your body is made, otherwise your body is actually exactly created. The elements in your body is actually created in the sun. So let me have a question. Like what I'm going to say. So you might have seen in your daily life we are actually calling as nuclear synthesis. Correct now? According to the process what we are calling as nuclear synthesis, every elements are actually synthesized in our sun body. So body, for example, you can see if you are doing any kind of if you are taking any of your cells outside, inside the cell nitrogen is there, then this nitrogen is not synthesized on our earth, it is actually synthesized on sun. The phenomenon I already told is nuclear synthesis. This nitrogen is synthesized in sun, then from where do you get this one in your body? This is actually because of the fact your body, earth and everything is actually synthesized on the sun as our parent star. So these all elements are all not from as your opinion and all. You might be having your own beliefs and all. They are not truths, your opinion, but these all are flops according to this theory. Okay, anyway, forget about it. I'm going to tell you about the elementary science. What is there in elementary science? First and foremost, let us focus on the fact what is an atom. What is there in an atom? Okay, tell me what is there in an atom. What do you know about an atom?
Nucleus, proton.
Yeah, exactly. Our atom is actually made up of. Okay, what is the charge of an atom? What is charge actually? What do you know about charge? What is the charge of an atom? Atom is positive and atom is negative. Is that correct? Actually, the charge of an atom is neutral. Atom is not at all having any charge. Why? Because of what is the reason of it?
There is equal number of protons and
Equal number of electrons. Where protons and electrons we can see around?
protons are in the center of an atom and electrons revolve
Electrons
around.
are involved according to Bohr's model, right? According to Bohr's model. It's not according to we are having Schrödinger's equation and finally we are having some of the most modern quantum physics and all. According to that, these all are different. Okay? According to Bohr's model, it is electrons are revolving around the. Okay. That is exactly correct. Electrons are revolving around the atom, and at the center of atom we are having our protons, neutrons situated inside the nucleus. Correct, exactly. Then can you okay? Then I will tell you about an analogy. What is the size of an atom to the nucleus? Shall we compare the size of an atom to the nucleus? For that I will tell you an analogy. Atom is here. As compared to the size of an atom, the nucleus is very small. How smaller it is? It is very, very small. How smaller it is? Your answer is very, very small. And how can you compare that size? To compare the size, I will tell you an analogy. Listen to me. Compare the size of the our school compound. Compare the size of our school compound. And you are right now. Imagine that at the center of our school compound, a house fly is sitting. House fly is sitting at the center of our school compound. We can scale the size of the atom to our school compound. Consider the size of an atom as compared to the school compound. And at the center of our school compound, a house fly is sitting there. That much is the size of the nucleus to an atom. Imagine that our school compound is, atom is as big as our school compound. As atom will be never to that size, but you know that atom is microscopic. If you are using a microscope, then you cannot see an atom. Atom is again microscopic, you have to use electron microscopes and also see in an atom. It's very difficult. Okay, then forget about it. Even then, right now I am comparing the size of the school compound. Atom is that bigger as our school compound. Even then, the size of the nucleus will be the size of the house fly right now sitting at the center of our school compound. That much smaller an atom is to the nucleus. So the nucleus is to an atom. Clear? Oh. What is there inside the nucleus? What is there inside the nucleus? Inside the nucleus, what we are having is protons and neutrons. What is the charge of proton? Positive charge and negative charge. Correct now? Positively charged protons and negatively charged electrons are there. Correct. Sorry. Neutrally charged neutrons are there. Electrons are already we discussed and it is outside the atom. So these electrons are revolving. So let me ask you this question. What is happening to the protons? What protons are doing there inside the atom? Protons are actually all positive charge. All positive charge we are keeping together, then what will happen? All positive charge we are keeping together, then what will happen? They will repel. Positive charge will repel. Okay, then let me ask you another question. After asking this question, I will come back to this answer. For example, I told you what is the size of the nucleus. In this tiny area, all the protons, if you are keeping, you consider our zinc atom. What is the atomic number of zinc? 30. Consider that one. So the 30 is the atomic number. Then 30 electrons are there in the zinc. 30 protons are there. These all 30 protons are actually situated or is confined inside the which nucleus? Zinc nucleus. 30 protons are there. All these 30 protons are actually confined in a small area. I told you already what is the size of the nucleus. It's very microscopic. This all 30 neutrons are, sorry, protons are confined in the small area. Then what will happen? They all will repel each other. Correct or no? There is a repulsion. The massive amount of repulsion will be there. Okay, so that is fine. What are the protons made up of? Have you ever heard of it? Protons are made up of? Protons are made up of? You can ask this question, you can decrease this question finally, you can do the reductionism. For example, atom is made up of subatomic particles. Proton, neutrons and electrons. What is electron is made up of? What is proton is made up of? What is neutron is made up of? Do you all have an answer? What is neutron is made up of? Neutron is made up of other subatomic particle we are calling as quarks. Quark. Have you, I think we have in our 9th standard syllabus we have to study, we got to study about quarks. Quarks are actually mentioned as simply the fundamental particles. Our protons and neutrons are actually made up of quarks. Okay now? Yes. So then tell me what is the, how this all elementary science are pointing us towards to the size of the atom, charge of the atom, we should be knowing that. So then tell me what is actually, what will happen with the all round of repulsion? If all positive charges are repulsive, then what will happen? Inside the nucleus, all the positive charges caused by the proton is repulsive, then what will happen? Tell me. What will happen? They all will repel with high round of electromagnetic force. The name of that force is electromagnetic force. And what will happen to the size of the nucleus? The size of the nucleus will become larger and larger. And it will become out of shape. One proton will go to here, another proton will go to here, another proton will go to here. Like that, it will become out of shape. So this is actually managed by the strongest force in our universe. That one we are actually calling as the strong nuclear force. The force is actually we are calling as the strong nuclear force. Strong nuclear force is actually used here for making our nucleus is in shape. It is managed by the nucleus. Okay, then we will discuss about strong nuclear forces and all. But before that, let me ask you about the Bohr's atom model. How many of you know about Bohr's atom model? Like according to Bohr's atom model, what is the shells? We are going to study about shells. Here, what are shells and how the electrons and protons are arranged? We have energy levels, energy shells. The shells are having discrete amount of energy levels. I mean, these shells are actually, for example, there is a probability in Rutherford's model. There are some of the limitations. By solving these limitations, we are going to the Bohr's model. Then we are having some of the exactly privileged energy levels. We consider them as K shell, L shell, M shell, and N shells. Okay. Then tell me about the what is the relation between atomic number? So you might have studied about atomic number, right? From any of the previous classes and all. Okay. Why not going to wind up this section? Let me know about what is the relation between atomic number and how these electrons are. If atomic number is 1, or if atomic number is 20, atomic number is 11, then how the electrons are arranged? Let me know. Stand. This question is from chemistry. Let me know what is actually, if electrons are arranged in the shells, how you are going to, for example, 11 electrons are there in your hand. How will you arrange the emissions?
Two shells in the
Okay, wait, you sit down. It seems that you are knowing. Stand. Here, here.
In first cell, two.
Three electrons to go. Okay, I'm telling you atomic number is 11. Tell me from the beginning. Atomic number is 11, then tell me from the beginning. I'm checking what you know. Atomic number is 11, then what is its meaning?
Two, eight, and one.
Oh, okay, that is exactly right. 2, 8, and 1. And what is the meaning of atomic number? So, note down this point. Meaning of atomic number means it is a number of protons or number of neutrons. Or, sorry, I'm sorry, number of protons. P for protons and electrons. Number of protons or number of electrons. Correct? No? Tell me. Atomic number is 11, then what is the meaning?
There are 11 protons.
11 protons and 11 electrons are there. Okay, then tell me what will happen to these 11 protons and the 11 electrons. How we can arrange them?
In K shell, 2, L shell, 8, and
M shell is
M shell,
1 electron. Which element is that one? This element we are calling as which element is that one? 11 to 1 is 12 to 1 is magnesium. What is this 11 to 1? 11 to 1 is sodium. So I will show you one chemical reaction and after that I will go into the section and ask you a question. Okay, then today we are going to know about the ionic reaction. So I'll tell you about since you are knowing each one, then I will show you about the atomic number of sodium is 11. We can consider sodium atomic number 11. And we can consider what's the problem of sodium according to Bose. Otherwise, what is the problem of sodium? Sodium is having a problem. So we go to the electronic configuration. For example, I'm write that one. Like in A shell, we have 2 electrons. Correct? No? In N shell, we will have 8 electrons. M shell we will have only one electron. According to us, you might have studied that all elements are having their stability. If on the fact their outermost shell is having 8 electrons, it should not be 1 electron. It should be 8 electrons. Correct now? It should not be 1 electron. For 1 electron, then what is the problem? The element is not stable. Correct now? So we have 4 different type of forces in our universe. In our universe, you might have studied about different types of forces, but all the forces we can categorize into 4. The first one is, we will start from the weakest one. The weakest one is gravitational force. The gravitational force which will attract the things towards to ground. Mass is there, the gravitation is there. Okay, we'll study in the next lesson, 10th lesson about. Okay, anyway, gravitational force is the weakest force in our universe. Reason of gravitation is mass. Mass is the reason of gravitation. Okay. Next one is weak nuclear force. You will study in the higher classes about it. After that, we are having electromagnetic force. Finally, listen to me, the strongest force in the universe is strong nuclear force. Strong nuclear force is the strongest force in the universe. Nothing can beat. That is why strong nuclear force is controlling the protons inside the universe. I already told you about strong nuclear force. It is the strongest force in the universe. Let me tell you one more thing. You can see here, every time, outermost shell electron should be 8. Otherwise, that element is like it will undergo some kind of problems. For example, imagine that some of the teachers are in the class are giving you some of the works, and they are all telling you if you are not doing the homework properly, then what will happen? Excuse me, here we go. If you are not doing the homework properly, then what will happen? Tomorrow they will give you the troubles. So you all will be, until or unless you will be finishing the homework, you all will be like in intention to finish the homework. Same like the atoms all are having a problem. If the number of electrons on the outermost shell, which is the outermost shell, I will show you that one. We have, I am drawing the sodium. This is the nucleus for the sodium. In the nucleus of sodium, what is there? 11 protons are there. Number of proton is equal to 11. Then we have 1, 2, 3 shells. First one is K shell, next one is L shell, the third one is M shell. In K shell we have 2 electrons, and L shell we have 6 electrons, and finally 8 electrons, and finally on M shell we have 1 electron. So this 1 electron is on the outermost shell. I already told you that 1 electron is not okay. It should be 8. So sodium is in a problem. Correct now? What is the problem of sodium? Sodium is having 11 protons and 11 electrons. But when we come to the case of electron, we needed to arrange all the electrons in the shell. We needed to arrange the electron. The first 2 electrons we already studied this one. That's why I am not telling you. Okay. So what is there? Finally, what we have in 1 electron on the outermost shell. In 1 electron, with this 1 electron, we are going to face the problem. What is that? This 1 electron is going to be the valence shell electron. Valence shell electron should be always 8. Okay. Since 8 electrons are needed to the outermost shell, we cannot give 8 electrons. We cannot help so. What is needed there? So for that, this 1 electron we are keeping here. We will keep this 1 electron over here, and we will consider another element. The another element is chlorine. Chlorine is the another element. This atomic number of chlorine, it is chlorine 7. Correct now? And we will have its electronic configuration 2, 8 and 7. Did you notice here? Electronic configuration of chlorine is 7. And outermost, then what is the number of proton is equal to 17. Number of electron is equal to 7. Correct now? It is okay. But you consider the sodium number of proton is equal to 11. Number of electron is equal to 11. Okay, fine. So we have a number of protons 17, number of electrons 17 here for the chlorine. So if you are drawing the electronic configuration, so if you are drawing the subshell, shell-wise configuration, we can this is chlorine. We have first shell 2, second shell A. The final one 7. Correct now? So what is the problem of chlorine? See here. It's a problem of chlorine. Chlorine is having 7 electrons on the outermost shell, and here 1 electron. Okay. This problem, if you are manipulating this, we can understand 1 electron is here extra. That means if you think about here, 8 electrons are there on the outermost shell, on the L shell. The M shell is having 1 extra electron. This electron is going outside, and you think that what will happen? This electron is gone. What we needed to do here? We needed to make the outermost shell electron as 8. Correct now? We needed to make the outermost shell electron as 8. Since the outermost shell electron is 1 here, we need to take it outside. So we will take this electron outside, then what will happen? 1 electron will come outside. And this electron, do you see whether it is making worth it or not? This electron we will give to the chlorine. In chlorine is having 7 only, we needed to make it 8. This 1 electron we have given to 7. Chlorine, then what is the problem? That problem is solved. Correct now? Really the problem is solved already.
Yes.
Problem is actually not solved. You have to understand one thing. From the beginning itself I tell you. Atom is having equal number of protons and atom is having equal number of protons and electrons. For example, 5 proton is there then 5 electron is there. 5 proton is 5 positive charge, 5 electron is 5 negative charge. So this 5 proton plus 5 electron, 5 positive plus 5 negative is equal to 0. That is why how many protons are there, that many electrons should be there in an atom. So the total number of protons and electrons are equal, then total charge will be 0. We can consider the case of magnesium. 12 protons are there, 12 electrons are there. 12 proton plus 12 electron is equal to 0. That is why when we come to this case, we can see here the total number of protons and total number of electrons are all same. But you consider this special case. We are in a problem. We should have only 1 electron here, but we have to have 8 electrons here. But here 8 electrons are already there. This 1 electron is extra. So we are giving it out. So when we are giving it out, the number of protons will be still there. But we have given this 1 electron, the number of electrons will become 10. The number of proton is plus 11, number of electron is minus 11. What is the charge of this atom right now?
Positive.
What happened here? 1 plus charge is extra. You can go addition that one. I hope everybody clearly understood what is the problem of sodium right now. Sodium is, once more I will tell you, sodium is having 11 electron and 11 proton. But 1 electron, when we come to the case of electronic configuration, 1 electron is extra because 8 electrons are needed for almost. 1 electron is extra there. 1 electron is extra, then we are giving it up. When we are giving it up, simply we cannot do that one. We have to do some kind of actions here. We need to do what we are calling the phenomenon as chirography. And we have to give energy to that. Correct now? So giving energy, then we can take it out. Correct now? Then if you are applying, if you are doing this action, then 1 electron will go outside. But the total number of electrons for the sodium will become plus 10. Sorry, minus. So we can do addition there. Plus 11 minus 10. We are adding that minus. Then what we will get? Our plus 11, 1 is extra, then it will become plus 1. Correct now? Then plus 1 times sodium. Then the charge of this sodium will become plus. Sodium will become plus. And we are giving 1 electron to chlorine. If we are giving this 1 electron to chlorine, then what will happen to chlorine? Chlorine will become chlorine is having 7 electrons in the outermost shell. 1 electron as a visitor it will go together. Then what happened here? Here 8. Correct now? Here also 8. Here it is 2. Then what is the total right now? It is 18. But number of proton is already equal to, we have already written number of proton is 17. Number of electron will become 18. What is the charge of electron? Negative. So we can do the addition here and we will get number of total charge we are going to find. Total charge of proton is 17, total charge of electron is 18. Okay? So we are going to find out the total charge. After finding out the total charge, we will get minus 1 plus 17 plus minus 18 will get minus 1 here. So we have minus 1 and minus 1 we are giving to chlorine, and we can see chlorine is minus 1 charge. Charge of chlorine is negative. So here what is going to happen? This is positive charge and this is negative charge. I have already told you we have the electromagnetic force, which is the second largest force in our universe. If two charges are separated by a distance, then the electromagnetic force will come there. And why is magnetic? F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R. So this is the magnitude of electromagnetic force. It's very high plus about it. Okay, anyway, what is happening here? Two charges will separate by a distance. If these two charges are separated by a distance, then a force will act between them. That force is the second largest force in our universe, that is electromagnetic force. So these two charges will separate and force will act. Because of this force, they will come together. This is sodium and this is chlorine. They come together and they form a bond there. That bond is called an ionic bond. Otherwise, an electromagnetic force bond is formed there because of the charges are separated. So this is called a sodium chloride. Sodium and chlorine is reacting together, and we have got a sodium chloride, the salt that we are really having it during the time of the that is actually. So let me ask you one question. Electromagnetic force is